Now here in this video we are going to learn a very important thing, which is nothing but handling the imbalanced data set. What imbalanced data set means, let's say if you have 100 records in total in your data set, and out of 100 only 10 are something which are having the negative flag, less rest 90 or something which are positive, for example in case of fraud detection, right? So if you remember this particular video, these videos, right, where we build a model to detect the fraud, right? So what we saw is over here we had quite unusual kind of accuracy score, where we were getting it 100% accurate, which is could not be possible. Why we were getting it? Because the data was highly imbalanced. That's why it was giving you the 100% of the accuracy rate. And when we looked at the precision, recall and F1 score, those were not too good, right? We tried different modeling techniques also, and we came up with some better result. But today what we are going to understand is how can we handle those kind of data so that it could be it could be used well in training our model, right? So what are the techniques that we can have a look? Now, before we start, let's have a quick recap on the code which we had covered in this particular video, in that particular video. So this was the code. What I have done is I've tried to recreate that over here with some lesser amount of data. So this is just because it was becoming difficult to handle it and run it over here. That's why I have just done some, I have taken some lesser amount of data. Okay, so here I have imported the data, and here I have created. So this is our data volume, which is this is the total data volume which we need to consider, right? And in this data, if you see, the total number of frauds are 8,000 approximately, and non-frauds are 80,000. So if you see, 10% is something which is approximately 10% of the total volume is fraud, rest is non-fraud. So this is where we say it's imbalanced data, which we require to balance before we finalize our model or we train our model. So what we had done previously is we did some sort of sanitization check. We checked out if there is any missing value or not, which was not existing at all. Then what we did is we dropped the categorical columns out of this data. So in this data we had the categorical column, for example this one, which doesn't, I mean, more of these were more of ID column, right? Name of origination account, from where the transfer was initiating, payment transfer, and where that amount was being transferred, right? Those kind of ID variables these were, right, which were not of much use for us. That's where we just dropped it. Next, what we did is this type, payment type. This was useful one. So what we did is we converted that into the we treated that, we did one hot encoding right over here. We have done the encoding thing for that, right? So into the data, if you will see, for each of the payment method we have a separate column created in which we will have 0 and 1 value. If you are interested in understanding that, please check out the previous video. In that I have covered that in very detail. Now, once I had this complete data cleaned and very good to use, what I did is I split that into two parts. One is for fraud, the other one is for genuine. I also did the further splitting, where I kept in one data set I kept all the independent features, and in this one I have kept the dependent feature, which is nothing but target. Then we splitted the data in trend test split. We created model instance, which is for logistic regression. We fit the model over here, then we did the prediction of that. We did accuracy test over here, and whatever came out in the accuracy test, I tried to plot that into the heat map, which you see over here. And we also tried to print the classification report. So this is what you're seeing. Now if you see the accuracy score, we are getting 96%, right, which is absolutely in favor of predicting the no fraud. Mostly whatever you put, 96% of the time you will get that as no fraud, right? So which is not possible, which may not be possible. So that's what we are going to learn over here today. So these are some of the most commonly used techniques which are used in handling the imbalanced data. For example, oversampling, undersampling, SMOTE, k-fold, and sample technique itself. So I'll be taking one by one each of these. Let me explain you what is what is oversampling, right? Why we should be doing oversampling, right? So let's say this is the total data volume, and this is how the segmentation is. Total data volume is 88,213. Out of is 80,000, which is not which is approximately it should not be 99%, it is 90%, 90.7%. Okay, so this is 90.7% is no fraud, and 9.3% is something which is fraud, right? So to handle this, what we're gonna do is, this is the minority class and this is the majority class. So minority class, we are going to do the oversampling for the minority class. So what we do is, so for this sampling technique, there are multiple methods. So we are going to start from the very basic level, from the beginner one, right? And over here what we do is, we are going to create the copies of, records which we already have available in our minority class. And here what I'm going to do is, it completely depends on you how many copies you want to create. For that, what I did is, I tried to make it equivalent to the genuine number of the transactions, right? So I had 80,000 genuine transactions, so, and I had just 8,000 of fraud transactions. So what I did is, I created 10 times the, I duplicated those fraudulent transactions approximately 10 times randomly, right? So that's how I ended up this many population, right? So, and that's how I have 50% balance into it, and I'll be training my model on this, and let's see how it goes. Now let me take you to the Jupyter notebook and let me show you how it works, right? So for example, over here, so what you see over here is, we have already segmented genuine and fraud, right? So let's see how many genuine transactions are there. Genuine dot shape. So these are 80,000. What and fraud transaction are, frauds are 8,213. So what I'm going to do is, I'm going to do this the oversampling for this one. So for that, there is one technique which is called simple sampling thing, right? So I'm going to call samples, and in this I need to provide the size of samples which I want to create. So size of sample I'm going to take as the total number of records which I have in genuine segment. Okay, so here I will say genuine dot shape, and out of that I'll keep the first instance. Let me show you what does this mean. All right, so you see, when you say shape, then it gives this, and then it gives this. So this one is 0th part, right? So that's where I'm getting this one, right? So this is the samples which we have, and that I can store. So this is going to be more than the total number of records. So genuine has 80,000 while the frauds are 8,213. So if you are taking uh, a sample of less than 8,000, then it is okay to go ahead like this. But here the total number which we are going to take as sample is 80,000, right? Which is higher than this. So for that we need to say replace equals to true. Replace equals to true. And this will be created over here, and I'm going to store this in this, let's say new. All right, or let me call it over, frauds over, and then let me take a shape of this and see what happens, right? So you got 80,000 over here. Now what I'll do is, I'll concatenate genuine and fraud both, right? So for that I'm going to say processed, because our dataset is named as processed. If you see over here, this is the dataset, right? So I'm going to keep the similar name, processed df oversample, right? Oversampled. And into this I would say pt.concat, and inside that what I'm going to do is, I will concat both of the dataset, genuine, and over here I would say frauds over this one. All right, and axis equals to 0, which means I want to put it one below another, right? And then let's just see how it looks. Shape. So now we got 16,000 records, right? Now after that what I'm going to do is, I'm going to do a train test split on this. So train test split. So before, if you are following this this video, right, so make sure that you have all these dependencies already installed, right, already available in your data, not data but in this session. Then only you will be able to use these techniques whatever I'm trying over here. All right, so over here what I'll do is I'll do the trend test split from here, and into this it is beautifully written, so that's where I'm just going to copy from here and paste it right over here. All right, so what it is saying is trend test is split, and instead of X and Y, what I'll do is I can rather, let me put here processed over. So I need to give the X of this data set, right? So out of this, I would just drop is fraud, which is the target variable, right? So here processed, I am just assuming that you are familiar with this trend test split. So, and I'm going to take it little quick. Okay, drop is fraud, and X is equals to 1, which means the column, right? And over here, what I'm going to do is I'm going to keep that part only, is fraud, and this is it. Over here test size is 33%. I'm going to make it 30%. Random state, I'll just make it true, so that every time when we run this it will take the same thing, right? And let's do this. Yeah, it is done. Now once this is done, we need to create we already have the instance of logistic regression. I'm going to try all of these things on logistic regression only, right? If you want to use a different model, you can of course try that. So I'm going to use logistic regression itself. Okay, now the next thing which I'm going to do is I will say logit dot fit, and into this I'm going to use xtrain comma ytrain. All right, this is done. Now it will fit the model. That's done. Let's do the prediction. Logit dot predict, and inside that I'm going to put x test, and let me store this inside prediction. Oops, x test. Okay, I need to make it capital letter. X test. This is done. Now let's just try to check the accuracy score. For that we have confusion matrix. All right, what I'll do is I'll quickly copy paste this part, so that it will show us very quickly, isn't it? So I hope you are familiar with this. So I'm just going to copy paste this, and let's see what is it that we are going to get. Confusion matrix. All right, so this is how we are getting it. Now the next thing I'm going to do is I'm going to print classification report, and inside that y test comma prediction, and let's see, let me just say print over here. All right, so it's pretty good. I mean, again, it is 91%, but what you see, how is it different from here? Let me take a screenshot of this. Right, so if you see over here, the accuracy was 96%, and you remember I said if it is 96%, most of the time it will end up predicting the entry as no fraud. So the problem over here was F1 score for this class was 77, right? And now you see how it has improved over here. That F1 score has increased to 90%. It means it is quite balanced, and there will be very less possibility that your prediction will be incorrect. Accuracy has reduced. Previously it was 96%, now it is 91, and the F1 score has increased, which is 90%, right? And for this class it is 91. So you see, for both of these two classes it looks quite balanced, right? So here you are saying 91, and here you are saying 90. So it is pretty much in sync. Now the second technique what we are going to try is undersampling the majority class. What does that mean is this one. So into this, if you remember, the minority class had the number of observation 8213, right here, and this was quite huge. All right, again this number doesn't seem to be correct. this one. So don't focus on this part. Let's be focused over here. So we in fraud segment we had 8,213, and in genuine we had 80,000. So what I'm going to do that is, out of those 80,000 I'm only going to pick 8,000, approximately 8,000 random sample, and those will be my genuine volume and this will be my fraudulent volume, and I'll combine them again together and then I will train my model, right? This is called undersampling of majority class. Again, I'm not doing anything here, even I'm not making any duplicates, it's just I'm picking random samples out of the majority class. Or maybe you can also say that deleting the records to balance with minority class, right? So let me quickly do this. So this time I need to do the sampling for genuine, right? Previously we did it for fraud, now over here. And I mean, this time I'm just doing the opposite of what I did previously. You see over here what I had done. I had sampled the frauds with the count of genuine. Now I'm going to do it the other way. I'm going to sample genuine with the count of frauds, right? So let me take frauds over here dot sample, no, not sample, dot shape, oops, shape, and over here this is what, and I'll take genuine, store it into it, and let's take the shape of genuine, 8,213. So here I'm taking the number of frauds data set, the volume which we have for frauds, that is the exact count which I'm keeping over here. But this is not important that I always keep this count. It is completely on you. Whatever numbers that you want to produce, you can put it over here. Now because I said that it is on beginner level, right? So I'm trying to keep it simple, that's why I'm keeping the same number, right? If you want, you can try it with different set of numbers. Now again I will do the concatenation, pd.concat, and inside that again what I'll do is I'll put genuine. Oops, I made a mistake over here. Let me quickly correct it, otherwise that will be a problem. Please bear with me for this mistake. Now over here I'm almost done. All right, so over here I should say genuine under, right? So I should create a separate data set instead of overwriting the previous one, right? So let me just take genuine undersampled comma frauds, this one, and here I'm going to say axis equals to 0, and what I would say is process data frame, I'm going to create another one, and this time I'm going to say it under. All right, now let's just say shape. What is the shape? This 16,426. Now let's try to train the model. I mean, first we will do the trend test split. So this time I'm going to copy paste it from over here. All right, this will save our time, nothing else, right? And just all that we need to do is just change the dataset name over here, data frame name, this. All right, and let's just try to train our model, not train but this split. Then it is done, split is done. Then I'm again going to say call my model, log it, and inside that I'm going to put x train and then y train model.fit. Sorry, model.fit is done. Then after it is pretty quick because the number of records were quite less, right? Now I'm going to do the prediction, log it dot predict, and inside that I'm going to put x test, and this I will store in prediction over here. Now again what I'll do is I'll copy paste the things from here, right? Because everything I'm keeping the same, right? Name nomenclatures are absolutely same, accuracy, taste, etc, etc. Now let's just run this. Okay, and now let's print the classification report. Classification report, inside that I'm going to put y test first and then prediction, and let's just see. Oops, let me print it again. All right, so it seems like giving the similar result as we had over here. So accuracy over here was 90%, right? Over here the accuracy was 90%, and over here the accuracy has increased slightly again, but it looks more or less same. So you see undersampling and oversampling. This is how you can treat your data with undersampling and oversampling. Over here we are going to learn about SMOTE. In previous video we saw that we have highly imbalanced data where only 10% of the total volume we had fraudulent transactions, rest 90% was in non-fraudulent, okay, which means the genuine one. Now we learned balancing that data using oversampling and undersampling just by duplicating the records. Now over here also we are going to learn the oversampling the minority class, but not just by duplicating but by creating the synthetic records. Now how does that synthetic record works? Synthetic record creation works is that is based on k nearest neighbor, right? So some I mean, behind the story of this particular model, which is not none other than SMOTE, k nearest neighbor works. What it does is from the minority class it picks one record, right, and for that it will find the k nearest neighbor, and basis on that it will try to create some synthetic record for that, and that's how it tries to balance the data. I mean, creates the balance between non-front I mean minority and majority class. All right, so that's exactly what we are going to see over here, how to do this. Again, I'll repeat, SMOTE stands for synthetic minority oversampling technique. So to use this, it is important that you have this particular module installed in your system. In case if you don't have it installed, just run this syntax and you would have that, you will get that installed. Now after that, once this is installed, what you need to do is you need to import it. So we're gonna say from imb learn, from imb learn dot oversampling import SMOTE, right? So once this is SMOTE, once this is imported, we need to create an instance for this SMOTE, and we will just quickly create an instance for this. The instance is created. Now it's time to create in this also we would require to create trend test split. So before that we need to have two set of data, right? We should have the data is splitted in two part. One is for target and the other one is for the independent features, right? So what we had created in the very beginning, that's exactly what I'm going to utilize over here. You see this one, this is the segment I'm going to utilize over here, right? So to create this SMOTE, I would say x underscore SMOTE, then comma y underscore SMOTE, and over here I'm going to say SMOTE dot, here it has this function or method, you can say fit resample, and inside that you need to supply this data set, right? Independent is the set of all the features and dependent is nothing but the fraud flag. Okay, so this is what we need to supply, and after that it will be created. Let's quickly check the shape of the data, right? So for example, independent dot shape, and over here I'm going to just put it inside display so that we will be able to see other printing work also. X underscore SMOTE dot shape. Now what you see over here is this is true, this is what we had, 88,213 total independent, I mean total volume of the data, out of which these are just set of the independent features. So for dependent and independent, total number of records are going to remain same, right? So what it has done is it has done the balancing and it has created 1,60,000 records, which is nothing but 160,000 records, right? Now next one which I'm going to do is I'm going to create display, and inside that again I will use dependent dot shape, and after that display, here I'm going to say y SMOTE, right, dot shape, and let's see, bravo. So it also has the same sort of distribution. Now the next thing is creating the trend test split. Again I'm going to take this one from here itself, I will pick this, and this time over here instead of keeping this set of data, we will use this X SMOTE and Y SMOTE. X SMOTE and Y SMOTE. So this is what we are going to use for our training purpose this time. All right, now this is done. Next thing which we need to do is train our model dot fit, and inside that I will use X train comma Y train, and this is done. Then next thing which we will do is, of course, we will do the prediction dot predict, and inside that we are going to say X test, and let's put it into the prediction, right? And this is done. Prediction is done. Next, let's try to create the confusion matrix. And for confusion matrix, again I will use, first we would require to create, of course, accuracy test, right? And over here I'm creating the accuracy test, and then I'm putting that into the heat map. Over here you see accuracy test, and then these are the parameters to create the heat map to make it interesting. Okay, and let's just see what we get. All right, this looks pretty well. Now let's just see the classification report. Classification report, and into this one we are going to use Y test comma prediction, and let's just see what is it that we get. Let's say prediction, sorry, not prediction but print. All right, so what do you see over here? Wow, this looks pretty cool. Everything is pretty much in sync. Accuracy is 91%, F1 score is 91% for both of the class, and recall is 90% for this class, minority class, which was the minority class, and 91 looks for majority class, right? So this looks pretty much in sync, isn't it? So this is how you see, I mean, it's quite good technique to use to balance our data SMOTE. Right, so I highly recommend you to utilize this in your data balancing work. So this is what this is it in this video. In the next one we will try k-fold cross validation and ensemble technique, right? But this is one is this one is very, very useful. Do try this exhaustively, and I mean extensively rather, I should say. Okay, and let me know what is your experience into the comment section. In case if you find there was some of these steps which could have been handled in much better way, do let me know. I'll also learn it from you. Now in this one we are going to use k-fold cross validation for the purpose of balancing the data. So this is not the only purpose of k-fold cross validation. It is used for model selection also, and for data balancing as well, right? So here we are going to utilize this in the context of balancing our imbalanced data. So if I have to tell you what exactly the cross validation is, so here I'm going to create one demonstration which will help you to understand what exactly the k-fold cross validation is. So you consider this red bar is whole set of your data, which is containing somewhere 88,213 records, right? This is the whole set of the data that you have. Now in k-fold cross validation, what we do is, it's nothing, it's simple. When you create a logistic regression, what exactly that you do is you split your data into 70% and in 30%, right? And then you do the testing, correct? You do the you train your model on 70% of the part, and you test that on 30% of the part. In cross validation, what we do is we split the whole data in n number of segments. That segment is also called fold, right? So for example, here we have this data set 1, and I am splitting that in two parts. One is training set and the test set. So not exactly two part, I am splitting my entire data in 5 segments. Let's say I splitted it in 5 segments. So first 4 segment I'm going to utilize that as training set, and the last set I'm going to utilize as test set, right? So this is how I'm going to utilize in the first iteration, right? This is the first iteration. In second iteration, what I will do is, if you see, the 5th set I have included in the training, and the 4th set I'm using for test. Same way, in the next iteration, what I'm doing is 4th, 5th, 1st and 2nd, all of these segments or folds I'm using to train my model, and this third set or fold I'm using to test it. So what exactly that is happening over here is in every iteration what happens, a new fold from the training set comes for the testing, and whatever we had in testing set that goes back into the training. So it's kind of cyclical training, right? It is happening, if you see, it is happening in loop in each of the iteration. And that if you do it this way, what happens, your model sees each kind of the data, right? And it trains itself in on all sort of the data. It will have the knowledge of all overall, I mean, idea of your whole data, right? And basis on that, it would have better understanding. Okay, now once it is done, so that's how it keeps on iterating. And once it is done, what we do is the whatever score comes out of it, we average that, and that's where we conclude the model, or maybe the data balancing. So you see, these were the three iteration. In fourth iteration, what will happen is second fold is going to be used as test, rest is as training, and so on in fifth fold. So this is what happens in the k-fold cross validation. Nothing much, no rocket science, it's very simple. Okay, now let me take you to the Jupyter notebook and help you understand this over there. So over here, to start with, what you need to do is from sklearn model selection, first of all you need to import this stratified k-fold. Okay, once you are done with this stratified k-fold, then what you need to do is you need to create the instances. So here I'm going to explain about k-fold cross validation. So here I'm going to create one instance, let's call it k-fold equals to this, and into this you need to provide how many split that you want to make. So in I mean, ideal split is 5. In our consideration also, we are going to keep it 5. If you want, you can make it 10, you can make it 3, you can make it 4, whatever you want. So I'm going to keep it 5. Number of split is 5. Then shuffling I'm going to make true. Shuffling I will make true. Then this is done. After that, so because this will be splitted in 5 parts, so it will be a series, I mean, or maybe yeah, it will be a number series. You can also consider that just like a list, right? So we would require to iterate through each of the elements. So for that we would require to use for loop. So I'm going to say for train index and test index, because we have to split this, right? Index in k-fold dot split, k-fold dot split. So k-fold is nothing but this instance, and that using that k-fold has a method or function, you can say. Using that, I'm going to split my data in training index and testing index. So to split that, here is what I have, right? Independent and dependent features, right? So let me take this. I will take this only, right? So independent set I'm going to use over here, and then here I'm going to use dependent set. All right, this is done. Then I would require to create xtrain, xtest. For that, what I need to do is I will take, for training data set, I would use independent set of data, and for the testing, the dependent one has to be used. I mean, not exactly what I said is true, right? That is not true. So independent is the whole data set except the target variable, and into this everything is not available. I mean, it has only the target variable available. Okay, so let's split this one first in training and test, right? So what I'm going to do is I will say independent dot iloc, and inside that I'm going to put this one training index. Same thing I will again do. Oops, sorry, please bear with me. I need to put square bracket over here. Then again I need to use independent data set iloc, and then inside that I'm going to use test index, right? So the set of features which I had, now that is splitted in training and test. Next thing, the target variable also I need to split that. Okay, train y test dependent dot iloc, and inside that again I'm going to use train index, and then I'm going to again create dependent dot iloc, and inside that I'm going to use test index. All right, this is done. Now trend test split is done. You are aware once trend test split is done, then what exactly we need to do is we need to fit our model. So to fit our model, here is the logistic regression instance I have already created. Let me show you that. Logistic regression instance I have created over here, right? So let me just make sure that it is initialized. Okay, so that is initialized. Let me go down again, and over here I'm going to say logit dot fit, and inside that I'm going to use my xtrain comma ytrain, right? This is done. Then logit dot predict, and inside that I'm going to use xtest. This I will store in prediction, that is stored into the prediction. Now after that, sorry, I need to say equals to. I will also try to take the score of it, right? And let me say score equals to logit dot score, and inside that I'm going to take xtest comma ytest, and over here prediction. Okay, now after that what I will take is confusion matrix. Okay, confusion matrix, and inside that what I'm going to say is, let me put it into the accuracy, and inside that confusion matrix I need to use prediction, and the next one what I will use is ytest, so that I could compare it. Then classification report, I will also use classification report. Now into that let me say classification report, and here I'm going to say classification report. Inside this again prediction and ytest. All right, this is done. Now so what will happen is, because we are going to split the data in 5 segments, right? So every time it will run and it will fit the model on each of the set. It will do the prediction, it will create score, and then it will create the confusion matrix, and this everything, right? So what we exactly need to do is we need to put it in certain storage area, right? So here I'm going to create one thing, blank list for score. Into this I'll keep on storing all these scores, right? Then for accuracy I'm going to just or let me say cm confusion matrix, and that I'm going to use over here, and then classification report I'm going to use over here, right? So once this is done, what I will do is I'll keep on appending them. So I'm going to remove it from here, and I would say append, and let's append it over here. Same way I will take this confusion matrix and I'll put over here, and no requirement to store that in any temporary variable, but here I need to say dot append. All right, now let me just see this class rape again, classification report. This is nothing but the classification report, and here I would say dot append, and again let me just store it. All right, I think we are pretty much sorted. Let's try to execute it. Let's see what happens. Well, that is done. Now let's see what all that we got in scores. All right, so you see here 5 scores we have got: 95, 95, 95, 96. So approximately for each of the fold, that is working pretty well, right? Now let's print the confusion matrix. Confusion matrix, you see this is how it is looking. Now let's see the classification report. Classification report, this I would require to do this thing for I in classification report print I, so that it could look a little better, huh? This is first iteration, second iteration, third, fourth, and fifth. So you see in each of the iteration it is looking pretty good, right? 96% is the accuracy, 78% is the F1 score, right? Here 76% is the F1 score, 76, 76, and 77. So F1 score is in the range of 79 I mean 75 to 80, right? And accuracy is above 90%. So this is what we have got over here. And if you compare it with the previous techniques, I think SMOTE worked pretty well, right? So SMOTE had performed pretty well. In this mode, we had got the F1 score of 91%, right? In SMOTE, we had got it for 91%. So that worked pretty well. K-fold cross validation is also working pretty well. That's not bad. 77 and 76 is pretty good as against to 38 what we were getting in the very beginning. All right, so I hope that it was easy for you to understand K-fold cross validation. I highly encourage you to go ahead and try to use it in your practical work. Ensemble technique. Before I start with explaining the ensemble technique in data science, right, let me try to help you understand what ensemble means in plain English. So if you go on Google and try to search for ensemble meaning, right, what it says is a small group of musicians, dancers, or actors who perform together. So what do you understand? It's simply trying to say that ensembling means a group of individuals who have who have their individual level of skill sets, and they are complementing each other, right? They complement each other and ultimately comes up with a uh, very wonderful solution, right? Very wonderful product. That's what it is saying, right? That product is entertainment in the case of musicians and dancers. So that's exactly what happens in ensemble learning, right? In this, what it happens is it combines multiple models together and complements each other. For example, in a group, one person can be, skilled in one thing and lacking in the other thing, right? So the other thing where the first person is lacking, the second person may complement. Same thing happens in the case of models in ensemble technique. So here it will be group of models, and when you try ensemble, then ultimately what happens is at the end you can come up with a very good result, right? That's exactly what happens in the ensemble technique. Now, all the techniques which we discussed previously, what we were doing is first we were treating the data separately, first we were treating the imbalance in the data separately, and then we were building the model. Here in this one, what we will do is we will directly fit the model, and in itself the model which we are going to be using over here is the advanced, or maybe you can say the latest version of the random forest, which is called balanced random forest. Okay, in that what it will do is it will create n number of trees, and which itself will be training on separate segment of the data. Internally it will create separate segments of the data and will train each of the trees, and basis on that it will come up with the final conclusion. All right, let's just quickly start. If you remember this SMOTE video, into that we use one library which was Imbalearn. Again, the same thing we are going to be using over here in Imbalearn. Let's say from Imbalearn dot ensemble, you see we are going to use the ensemble segment into the Imbalearn module, right? And out of that we are going to import balanced random forest classifier. There are two: balanced bagging classifier and random forest classifier. Here I'm going to use random forest classifier. Now once this is done, as usual we need to do the train test split, and inside that, if you remember, we had already created two set of data over here: independent and dependent. Independent is everything except the target variable, and dependent is only with the target variable. Okay, so let me very quickly complete this over here. First of all, I would say independent data, then dependent data. All right, and then here I need to provide the test size. Test size I'm going to keep 20%, so that I need to write like this 0.2, and then I'm going to say random state. You can put any number. Here I'm going to put 20. Now we need to store this. Conventionally we store it in xtrain, ytrain, xtest and ytest, right? Xtrain comma xtest then y train and comma y test. If you ever get confused what are these split, how to I mean, if you get confused with the naming convention, etc., so always you can do you can come into this train test split function and just do shift tab and expand this, go little down over here, and if you scroll down here you will get this split done. You see here it says x test, x train, x test, y train, y test. All right, so this is done. Now after that we need to create instance for this balanced random forest, right? So I'm going to say model equals to balanced random forest classifier, and into this you need to provide how many trees you want to create, right? Because we all know random forest is combination of multiple decision trees, right? So here how many decision trees that you want to keep. So I'm going to keep let's say 100 decision trees, right? And then again here also I'm going to keep random state, let's say 42 conventionally I'm going to keep this, right? Then once this model is instance is created, let's just try to fit this model dot fit, and inside that I need to put x train comma y train. All right, the model fitting is done. Now the next thing is let's try to find the score on training data. So it is still fitting the model, let's just allow it some time. Okay, that is done. Now next thing which we are going to do is going to find the score, model dot score, and into this we are going to use the training data itself so that we could check key what is the score that it is generating, how accurately it is doing the prediction on training data first, right? So training data, training accuracy on the training data or score on the training data is relatively higher than what it gives us on test data, right? So this is what it is giving. If you want to try it on test data also, you can try that, model dot score, and into this you can say x test comma y test. Let's just see, it is like you can see here it has given 98 96 9896, here it is giving 9871, right? So it is slightly lesser, right? So that is pretty much acceptable, right? Anything which is less than 10 or 8% of difference is I mean that's pretty much acceptable. All right, now let's just do the prediction. I'm going to create model dot predict, and inside that I'm going to use x test. The prediction is done. Now I'm going to print the directly I'm going to print the classification report. I will not get into that confusion matrix this time, right? I'm directly going to print the classification report. By now if you're following this series you must have understood how to create all these things. Now we need to provide the true value first and then the prediction value, right? And let's just see. Okay, I need to print it. All right, here it looks pretty good. Accuracy is 99%, right? And F1 score is 94. Accuracy is pretty obvious because the data was imbalanced. But you see, F1 score is also pretty well, right? It is saying 94. It is, I think it is the highest in all of the balancing which we have done so far. In all of the, what I can say, in all of the five techniques which we have used, out of that, this is the highest one. Recall is 100% and precision is 88% for this class. And for this class also, for the zero, of course, for the zeroth one it is 99, right? Which is obvious. But for this true class where it is fraud, for that also it is saying 94% of the time F1 score is 94%, which is quite significant in itself. If you want to understand what F1 score and precision and recall is, I'm going to drop the link into the description section. Please give it a watch. You will be pretty clear on that part. Okay, so so far the accuracy which we had got in SMOTE was 91%, and F1 score was 91. Accuracy and F1 both were 91 for both of the classes, and this is pretty well, I mean it's much better than that. Okay, Now, other than this, in the undersampling and oversampling also we had got 91, 91, right? 90 and 91. So this is the best result which we have got so far on all of the models. But I would encourage you to choose whatever you want out of these five. And sample is, of course, it is giving you the horizontal decision. Last one which we covered was the ensemble technique, which we had covered in the last video, which was ensemble technique. Now, what we are going to understand in this particular video is how to save the model which we had created in all the previous videos. Okay, in the previous video what we were doing is we balanced the data and then we trained the model and we did the prediction. So whatever models that we had created, we are going to save that, and we will save that in a way so that after saving that, if you want, you can share that with your friends, with your colleagues, with your client, and they can simply just put their unseen data into that and they can get the prediction. It is going to be that simple. Now after this, what we are going to do is we will also do the automation of all those steps which we took to clean the data. While we were doing the balancing of imbalanced data, we took some steps which were needed to clean the data. We are going to automate that, and we will automate that and we will put that in a module in a way so that next time when you require it, you can simply do import that module and you can just directly use that function to clean your data. You don't need to take the individual steps. It's going to be that simple. Now after that, once that automation part is once that data cleaning part is automated, we are also going to automate the SMOTE balancing technique, right? Because we found that balancing was very effective. So we will be using this balancing technique further to train if we have to train further models, then we can use directly SMOTE balancing in the similar nature of data. Then further, if we want to do the prediction, right, once all this automation is done, then what we are going to do is we are going to put unseen data, bring the unseen data, clean that using our automated data preparation function or module, then use the saved model to do the prediction. Once that prediction is done, we are going to concatenate with the input data and then put that into the Power BI and then do the further analysis. All right, so without further delay, let me take you directly to the Jupyter notebook and let me help you understand how we can start with it. So here we are back in the Jupyter notebook. First we are going to say, first what we gonna do is I'm going to save the models which I want to use further. So first one is ensemble technique, right? So this one I'm going to first save. So to save that, this is the module which you require, import pickle. If you don't have it, then you can just do the pip install pickle and that will be available in your system. Okay, so after that I'm going to write this step with open, and here you need to provide a file name. So I'm going to say this was ensemble model, right? Ensemble model dot pkl is the extension, and after that here I need to write a method. So that is wb is write binary. I'm going to define it as file, and then over here I'm going to say pickle dot dump is the method which we need to use right over here. And what we exactly want to dump, this model which we had created over here. You see over here we had created and we did the prediction. So this is the model which we are going to dump, and here I'm just going to write file. This is done. Now if you want to check where is this stored, so this is stored in your working directory. So to check that, you require this OS module, and into that OS get current working directory, CWD. Let's see. So this is my current working directory. Let me just try to open this current working directory over here. Into this I'll just put this one here. Here is the one which I have already. Now you see over here ensemble model pkl is saved. Same way we are going to save other models. So for example, k-fold cross validation, I'm not going to save this because I'm not willing to use this further. It was giving me the F1 score of 77 only, right? So I will just put it on hold. I will not use this as of now. I will use this one where I trained a logistic regression model using I mean, I trained the logistic model on SMOTE balanced data balanced with SMOTE, right? So here I have already reused the logistic regression which was imported previously, but here I'm going to create another instance. I will say SMOTE logistic, and here I will just create the instance of logistic regression. So remember, this you cannot do unless you have this thing imported. You see over here, I have this thing imported: sklearn, linear model, and logistic regression. So once you have that, then only you can do this. So now I'm back over here. This instance is created. After this, I will train train this model only. And after that, what else I need to correct? This one is done. Let me run this. Then prediction. Oops, there seemed to be some error. Okay, I didn't do the fitting of this model directly. I'm using this, isn't it? Okay, I need to do the fit of this model also. So what I'll do is I'll just write this dot fit. Into this I'm going to write xtrain. Let me first run this entire cell so that xtrain will not be confused. Okay, and over here xtrain is created. The same xtrain I will be using over here, and I will use y train as well. All right, now this is done, and after that I'll do the prediction, then run this. This is here, and let's then run this. So this is 9191. Okay, now I'm just going to save this model. Now what is this model? SMOTE logistic, right? Again I will use it because I have already imported pickle1, so I don't need to import that again and then again. I'm going to say with open, and here I'm going to say SMOTE. I'm going to keep the same name, SMOTE logistic dot pkl, and here I'm going to say wp as file, and over here I would say pickle dot dump, and inside that I'm going to keep the same name. I think I'll keep the same name. Okay, and the next thing is file. All right, I'm keeping the name same. If you want, you can have a different name. All right, so this is done. So we are done with the first step. We are done with saving both of the model. If you see over here, ensemble model and the other one, ensemble model and SMOTE logistic, both are saved over here. Next step which we are going to undertake is I'll do the automation for cleaning and the SMOTE steps, right? So here I'm going to say automate fraud detection data prep. All right, this is what I'm going. Okay, I might get the duplicacy on this. Fraud detection model data prep. Okay, model data prep. Let me say this: fraud detection model data prep. All right, this is done. Now let's do the preparation of this automation. I mean automation of this entire process. So first of all, this was our whole workbook, right? So out of this, what all that we require to bring. So if you are starting with any model development, right, any cleaning or etc., these are the basic libraries which you would require anyway, right? So I'm going to put this also over here. All right, next thing which I need is, let's say I'm done with importing the data, right? I will not automate the import process. Whenever I need to create the model or maybe do the prediction, then I'll do the import myself, and rest of the things I'll do using this one. Okay, so that's why I'm not going to put this step into it. Now the next thing which I will put inside that is this step. where I'm deleting these two columns from my data set. Okay, then what else? Then I'm creating the dummies. That step I will put inside my automation. Then I'm doing the concatenation of my data. That step I'm going to put inside it. And after that, I'm splitting that into independent and dependent, right? This is what. Now I need to do this def data prep automation, and inside that, what all I require is input df. I just need to put the input data inside this. Rest everything will be done automatically. So remember, you cannot use this method on any kind of data. You can use this method on only on that data which has the same structure. When I say same structure, that means the data look like this. When you import that, that should necessarily have all these columns, right? If you have all these columns, then only you can apply this data cleaning steps. So now you might be, if you're thinking, then what is the use of this? The use of this, if you're working in an organization and if you are creating the model development process, you are expected to have a process where, I mean, you're supposed to have a process where you will be getting the data in the same standard format. If yes, then you are going to be using this again and again. You will be able to use this again and again. If you are going to get the data in different format every time, there is no use. Every time you would require to do the data cleaning and bring it into separately and bring into this format. Okay, so this is created, this is done. Next thing which I'm going to do is I will automate this SMOTE balancing, right? So let me see where that SMOTE balancing steps are. Here are these steps, right? So first of all, let me import this if that is not imported at all. Learn oversampling import SMOTE. Okay, this is done. In case if you're going to use this, and if you think that learn is not available, make sure that you first install this. Otherwise this automation will not work for you. Okay, if you get any confusion, do let me know into the comment section. I will definitely try to help you out on how to install that. Now this is done. In the here I did the separate splitting again, but in my case over here, once my data cleaning is done, over there independent and dependent part is already done. Over here I missed one part. Here I also need to do the return statement. I need to write the return statement. Return independent, this part, sorry, this comma dependent. This thing I would require to do the return. Now once I get this independent and dependent, I can directly put that into this SMOTE analysis over here. You see over here I can directly put that. So that's why I will not utilize this step. I will directly jump to this one now. Okay, this step is done over here. Next thing, this SMOTE require a separate trend test split. So I will do the trend test split separately for this SMOTE one. Okay, and this again I'm going to do. I really need to do this? I don't think, because I have already trained this model, so I would not require this. In case if I need to use this mode, I will just do the cleaning and I'll do the trend test split, and after that I'll directly utilize this mode logistic, because that is something which I have already trained, right? And now over here what I'll do is I'll say return these values, these all four values. Now these steps, you see how simple is this? I'm just doing the copy paste from this step where we had already performed this sort of cleaning, right? So def, and here I'm going to say SMOTE balancing, and inside this, what exactly that we need to put? We need to put features and target. Let's say features and targets. After this, we would require to do some bit of correction. Over here you see I'm will learn oversampling. Wherever I have independent, I'm going to say, let's just put this independent and dependent are going to be features and targets. Okay, now this is done. Features and targets are further splitted into this part. Same way here we defined input TF, and over here we are using the TF, so that will throw an error, right? So let me correct this. Okay, where is this new TF coming into the picture? Processed TF, new TF dot prep. New TF is here, right? This input TF is done, right? This looks okay. This looks okay. Okay, this is pretty much good. We are done with this. Now, once you are done with this, next step which you should be performing is to save this one, right? So what I need to do is, see, currently this is a Jupyter notebook file. This is saved as Jupyter notebook file. What you need to do is you need to save this as .py file. Then only it will start working as a module. Otherwise it will not work as a module. Okay, so for that what I'll do is that you can do go in file, download, and from here you need to make sure that you download with this python.py. You download this. Once this is downloaded, you need to go in the download folder. Okay, let it complete. Show in folder, and from here it is important that we copy it and put that into the working directory. Okay, so here you see fraud detection model prep, model data preparation. Okay, so I'm going to take this and I'm going to go in this one. This is my model, this is my working directory. This is done. Here we got this. Here is what we got. Okay, model this is the code which we had saved, and this is the module. Don't get confused with model and module, right? So this is module. Now once you, if you want to import that, then it will be very simple. You are done with this, and this is the next step is going to be super fantastic. How? So I'm going to open a new workbook further. Let me open a new workbook. While this is opening, let me show you the another data set which I will be using to do the prediction. So if you see in this one, here you see to test the model, I have a data set which has approximately 5,000 records, and that data I am going to use for the prediction purpose. And for the prediction purpose I will be using this data. Once this is done, right, then what I'll do is whatever prediction comes out of that, I will put that over here, right? I'll put that over here, concatenate that, and then I will take it into the Power BI for the further analysis. So you see into this you have 4,500 records, and out of 4,500, how many fraud transactions that you have? Out of this you have only 500 for fraud transactions, right? So this is the data which we will be using in our prediction work using the automation part. Now this is done. After this, what we are going to do is I'm going to say import the model, the module which we had just automated, that was named with this one, right? Fraud detection model data prep, right? This is it. So this is exactly what you need to say. Import this as, I can say, as data prep. That is done. So it is importing it. Now this is imported. If you want to see what all are the functions that we have stored into it, then let's just say that data prep, and we need to call this one dir. So into this, if you see, we have label encoder, these all are the things we have. Classification report, we have confusion matrix, we have data prep automation. You remember this data prep automation function which we had created, that is available into that. Then SMOTE balancing, this one SMOTE balancing which we created, that is available into that. right? SMOTE balancing is there, trend test split is there, so everything is available into it. Now let's just start. So the first thing which I will do, so if you would see into that, you have PD also. PD means pandas, yes. So into this module you have pandas, numpy, everything, so you don't need to use that separately. So let me just say input df equals to this module, and out of that I'm going to use PD, and out of that I'm going to use read excel, right? And then let me just go back over here, this one I will do copy as path, come back over here, and let's just put it. Don't forget to put R, because if you don't put this you would require to change this slashes in the from backslash to right slash. Okay, now this is doing the import. Done. Now let's just try to check this out. Input df dot head. Bravo. So we got the data into it. Now let's just check the shape of the data. We got 4500 records. Super. Now you see how simple, I mean, this proves that our module is working pretty well, right? Because you see this was the module, and inside that we have this pandas, and out of the pandas we are using this function directly to read the Excel file. So this proves that our module is working pretty well. Now let's just see if our data preparation, data cleaning part is also working pretty well. Okay, so if you see data preparation module is this one. So what we need to do is first use this module, okay, over here, and out of that we need to see which one that we require to use for data preparation, data prep automation, right? And inside this you need to just supply the data, input df. So if you would say, if you remember, so if you run this, if you do this data cleaning, what is the output it will be giving? It will be giving you input and dependent, sorry, independent and dependent, right? So accordingly you require to create two more variables in which you will be storing these two outputs, right? So for that I'm going to create one is called features, and then the other one I'm going to say target, right? Once that is done, then let's just check what is it that we got in features dot head. Bravo, we have this, right? And let me just check the shape we got 12, and see into this one we should not have the is fraud, right? We should not have that target column available, we don't have that, right? So is fraud is dropped, other unnecessary things are dropped, and this was the payment type. Payment type is converted into this true false boolean values, right? There was one column which in original data we had one column which is called type. All right, so now that we are done with cleaning the data, the next part which comes is doing the prediction. So for that prediction, you remember we had two models saved in our folder, in our working folder. Where is that working folder? Let's just find it out. Okay, let me just find out the working folder. I don't have that. This one, this is the one where we had our working which is our working folder, and you see these are the two models which we can try to use. So first one I'm going to try using this one, ensemble model.pkl, this one. So how to make sure that we can use it pretty well. Okay, so for that next thing which we can do is pickle was not available in our automation part, so we would require to import that again, right? Import pickle, and here I'm going to say with open inside this model, comma, this time I'm writing rb means read binary as file, and then here I'm going to say loaded, or I can directly say this ensemble model equals to pickle dot load, and inside this I can simply say file. that is imported. Now comes the time, examination time, whether what is going to happen, right? Let's just say features done. Oops, it looks like object is not callable. It says ensemble model. This is not callable. What is the issue? Let me just see. Let me find it out. What's the issue? That object is not callable. Why is that object not callable? That we need to figure out. Alright, it is not callable because I am simply saying model, right? So I need to tell it what exactly that I'm looking for, right? So I'm looking for prediction. So let me just do this. So here is what we got. We got the prediction. Let me store this into it. Prediction. Let me write a variable prediction equals to this. And now our prediction is created. Let's just see the length of the prediction which we have done. 4500 predictions are available. Next thing, let's just check the classification report. Okay, so you remember classification report we had we have available in which module? In this data prep module, right? So I'm going to say data prep module dot classification report, and into this, so you remember for classification report you need to provide two things. One is prediction, the other one is truth. So truth I have available here you see features and target we had splitted. So here I did this just for the testing purpose. In real life, when you are going to use your model, so you would not have the target available, right? You can directly utilize the features, so you don't need to do this classification report and all those things. You can directly go ahead and use this prediction wherever you want, right? Now after this, what I'm going to do is data prep dot classification. Into this, the truth is target and the prediction is prediction, right? And let's just see the thing. Let me make it look pretty. Print, and after this you see over here we got 95% of accuracy. This is wonderful, right? Now the next one, I'm also going to do the same prediction using the other model. The another model which we had was named, what was that named for? This one, correct? SMOTE logistic pickle. Let's just see SMOTE logistic pickle. How is that going to work? So you see, we are not again developing a model or training the model. Already the model which was already created, we are just directly using that. So every time whoever wants to use your model, they would require to do this load, and once that is loaded, after that they can simply go ahead and use that. So SMOTE logistic dot predict, and inside this I'm going to put my features again, features, right? And let me say SMOTE prediction, SMOTE log prediction. All right, and let me just print this. Oh, we got this. It looks pretty similar, right? So now let's we got the prediction from this model also. Now let me prepare the classification report again over here, and I'm just going to change this one. You see, so our previous one, ensemble one, is of course working much better, because you see this is giving us only 71% of the F1 score for this class, for minor class, and this one is giving us 95%, right? The other one, so anyway, I'll take both of these two predictions, right? SMOTE log prediction. The other thing, you remember this one is a logistic regression model, right? So logistic regression also provides you the probability functionality, right? So let me just show you that. Here I'm going to say probability, okay? And after this, over here, let me just say prob dot predict probability, okay? And predict probability, let's just see what comes out of it. This would have the probability predicted. So out of this, you see it is this column is the prediction, probability prediction for wherever it is not fraud, negative class, and this is for positive class, means wherever the data says it's a fraud, right? So we require only this one because that is what we are trying to predict. Okay, so for that what you can do is you can just do this thing. Okay, comma 1, let's just see what it does. Bravo, right? And let me just store it into this, let me call it data. Done. All right, so we got three things, right? This one, then we got the prediction, SMOTE logic prediction, and then we have this ensemble prediction also. These three things we need to concatenate with our feature data, then only we will be able to use that in our Power BI. Okay, so that's what I'm going to do. Let me just try to zip them all together. I can directly do this. What we say, final data, let me say final data equals to data prep dot pd, all right, pd dot data frame, and inside that what I would do is I would use zip. Okay, and in the zip concatenation, let me create zip this all together. Okay, this one comma this one, log prediction, probability data, and there was one more which was just this prediction. Okay, I'm going to put this also, and then after that over here I would say columns, and into the column I'm going to put the list prediction. Here I would say ensemble prediction, then this two SMOTE, let me call it SMOTE prediction, and then SMOTE probability. All right, let's just see what happens. Dot head looks pretty well. Now the next step is creating the final data, final outcome. Let me say final outcome. I know the video is turning out to be a little longer, but you see this is going to be the interesting one. This is something which is providing you the end solution. Okay, so don't worry about that. Then again, this is the module which we have. Out of that I'm going to use the PD, and then over here I'm going to use concatenate function, and I will concatenate it with features comma final data, right? And over here I would say axis equals to 1. We need to concatenate side by side, right? Whatever outcome that we have got, we need to put it just next to the final features which we had already. Dot head. And what I'm thinking is, I think I should use target also into the same one, right? I will put the target also, which is my original data, right? So let me put target as well. Target, and here I would say is fraud. That was the original data. Okay, let me do that, and then over here let me do this. Bravo, we got it. So this is the probability, this is SMOTE prediction, ensemble prediction, and this is reality, this is the truth. Now next thing which I'm going to do is I will just export this into Excel, and inside this I'm going to put the location where I want to export it. I will be exporting it in this location. Let me do this, data for analysis, and don't forget to put R over here, and don't forget to put the extension XLSX. Now let's just run this. Well, this is done. Next thing which we're gonna see is, please bear with me, over here, data for analysis. We got this data for analysis. Once this comes, we'll just do okay. So this is something which is not needed if you don't want that to be exported. So what you can do is over here you can always write index equals to false, right? That will not produce that data. This is back over here. Now let's just see how does this looks like. So this is my truth. Let's see, whatever the true fraud was, whatever in reality we had the fraud 400, sorry 500 records we had which were fraudulent transactions, right? Now out of that ensemble one has predicted correctly how many? 499. Ensemble predicted 499 correctly, right? And SMOTE had predicted 452, right? So, with SMOTE logistic, we had got 452. So you don't worry, you don't think that this is something which is SMOTE which is reducing the accuracy. No, this is the logistic regression, and into this one for ensemble we had used random forest, right? The latest random forest name was, let me tell you the name, this balanced random forest, the balanced random forest which we had used. Now let's see, for this genuine class, means wherever the transactions were non-fraudulent, how many of them are correctly predicted by ensemble. So there is one which is incorrect. No, there are quite a few. Out of 400, 49 were non-fraud, but our ensemble technique said that this is a fraud, and our logistic said 31 out of that it said that it was the fraud. Now how many were truly predicted? So truly predicted was 3951. Means you see, out of 500, sorry, out of 4000 approximately, yeah, out of 4000, 3951 were correctly predicted. So it is quite good model, right? Rather I would say column n. Column n was the prediction. So this is quite a good prediction which we will further take into the Power BI, and we'll do the further analysis. We will see, we will focus on this probability. This is probability. What is the probability of this particular transaction being a fraud, right? That's what it says. So for example, if you take one from here, is fraud, out of the is fraud. So for this one it says that it is 99%, probability is 99% that this is going to be a fraudulent transaction. So if you will see, for all of them the probability would be more than 50% over here. If you would see, this is kind of non-readable, right? So that's why it is becoming like this. But yeah, this is how it is. So let's try to analyze this into the Power BI further. So before we start analyzing this data into the Power BI, little bit of the modification in the data which we need to do. Not exactly the modification, what I would suggest is this, we should rather say transformation, right? So what you see over here is false and true. I'm going to change that to 1 and 0. All right, so that's exactly what I'm going to do, right? So let's just start with it. Anything else that I would require to do? No, for now let's just do this, and later on if anything else is needed, we will see that how that has to be performed. Okay, all right. So before we proceed with that, I will create a copy of it, and here I would say dot copy. Done. Now out of this, what I'm going to do is I'm going to take columns. Let's just see this one, and this is a very important and interesting technique that you will be learning. Okay, so what we have to do is, in all of these 4 columns, you see, in all of these 4 columns, wherever it is true we need to replace that with 1, and wherever it is false we need to replace that with 0. All right, so here I'm going to say for x in dot columns, here I would say x equals to x dot where actually it should be np dot So np is nothing but numpy. If it is not installed in your if you have not imported it, then this is not going to work. Okay, so what I'm saying is in each of these four columns. Okay, before that let me make a list of that column particular let me make a list of all those particular columns. These are the columns which I require to work on, so that I'm going to put columns requires modification, and over here I'll put this. Let me just quickly complete this. This is little manual, so we can't help with it. Okay, not everything, something there would always be something which you require to manually work at least once. After that you can automate that. You can automate this part also, right? And now I will take this one over here. I don't need to look through those columns. Okay, the entire columns. Okay, now what I'm saying is go through each of the column in this list and find that and replace that with this condition, right? Equals to true, then put 1, else put 0. Okay, so what I'm saying is start the loop, and so the first column will be cache in, because in this list first column, when first iteration runs, it will find the cache in, it will put cache in over here, and it will check if cache in equals to true, then it will replace that with 1, else it will replace that with 0, right? So this is okay. np is not defined, so you see how it just gave the error. So what I'll do is over here import numpy as np. Let's just see. Done. Next thing which I'm going to do is check out the headers, head top few records into this. So now you can see here all the true false have been replaced with 0 or 1. Right, now the time is to replace the, I mean export this data into Excel and take that in Power BI and do the analysis, right? Let me just do this. I'll replace the older data, okay, because that's not needed anymore. It's just doing the export. Now there is one thing which I again missed to do here. I need to say index equals to false. Let me replace it again. All right, that's done. Let's go back into the tables folder, and the latest one is this one, the 1st January 2024. Let's just quickly have a look what is it that we got in this data. Hopefully everything should be fine. Yeah, we got all the data which we require. Now let me take this into Power BI. I'm going to get into the Power BI, and into this, while this is opening in Power BI, we are going to do the comparison of our prediction against each of those variables. Okay, against each of those variables. Let's just see data for analysis. This is the data. While it is coming up, let me show you what is the analysis that I wish to do. You see here is something which I have already created. Now you see over here, this is amount here. Oops, it's taking a bit of time. We are done with our importing the data. Before we start with the analysis, like I said, so this kind of visualization or maybe analysis we want to perform here. If you see here, what it says is amount you are seeing at the x-axis and the prediction you are seeing at y-axis. So 0.5 is nothing. What we are concerned about is 1 and 0. 0 means no fraud, 1 means fraud. So what you see over here, amount, the amount, transaction amount which were less than 50,000, mostly in that bracket the fraud has happened. Wherever old balance origination was less than 20,000, over there only majorly fraud has happened, right? So what you see over here, that is the fraud indicator. So this old balance originator or at the time of origination is a very significant contributor to make the prediction, you like you can see over here. And in the amount also, this amount column is also seem to be a strong contributor in making the prediction. Rest, this looks quite scattered. If you see over here, the fraud points are looking quite scattered. In this also, this is also adding a good value, but not as strong as these two are. So this sort of analysis we are going to perform, and once you have this sort of visualization created on the model output, then every day you just run the model and refresh this dashboard. It will keep on showing that fraud which is happening in what amount bracket that's taking place, right? Majority of the fraud is happening in which sort of uh, amount bracket. Okay, so if you are someone who already know how to do these things in Power BI, then you can stop the video and you can start developing this thing. Anyway, I'll be putting a link of this file into the description. But if you're someone who want to understand how I actually create this kind of visualization in Power BI, stay tuned, I'll create it. Okay, now let's just go back over here, and into this what we have is here we got all of the things, right? So I mean, I just don't want to make it further longer video. That's why I'll directly be starting with creating the specific scatter plots, otherwise you might find it very lengthy. So over here I need to check it as against to amount, and these things ensemble prediction I want to put on y-axis. Okay, ensemble prediction. One thing which you need to do is you don't require to sum it up. Okay, and you don't need to sum this also. Let's just work it out. So it is just processing. The data is little heavy, that's why it is taking time. Okay, so this we are done. Like you can see, here is the amount. Now here it is showing the amount in millions. We need to convert that into thousand. Let's go in x-axis, and over here in values you just need to change this display unit to thousands. All right, that is done. Now the next part which comes is title. So title, I would just say over here, fraud prediction against amount. All right, this is done. And against spelling is not correct. Let me just make that correct. All right, this is done. Now let's just come back over here. If you want to make the modification in these columns also, that's something which you can do. I'm not going to invest time into that because otherwise the video will become more lengthier. Okay, now let me just do the little bit, because the data is little heavy, that's why it is taking time, right? It's not able to handle it well. The when I say handle, it means the volume of data, right? I'm just doing a little bit of modification into the formatting. Okay, not much. Now the next thing which you can do is you can just do a copy paste of this one. Okay, and into this, instead of amount, what you need to do is you just start putting the other amount columns, I mean continuous columns which you have, like amount origination, destination, etc, etc. Before this, let me just make this border so that it will help us to highlight the things. Okay, visual border. Okay, now that is on. All right, this is done. Next thing which I will do is I'll just copy paste this particular chart. This is little slow because of the volume of data, right? Nothing else. So over here in x-axis I'm going to remove amount, and instead of that what I'll do is I'll use old balance destination. This is what I'm going to use, and into this again I'll convert it to don't summarize. Then again I will make a copy of this. but there is one thing again I need to change, and that's the heading title. Okay, into this old balance destination we are done. Then we need to use new balance destination. New balance destination, let's just put this and again change it to don't summarize. Okay, and then we will just change the title also. New balance destination is done, and in the title here I'm going to change it in the title fraud prediction against new bal. All right, so what I did is I had paused the video to just make this modification, right? So now what I'll do, I'll just make the adjustment in the size. I'm just trying to show it so that you could also learn Power BI. At least if you want to learn Power BI from scratch, and if you want to master it, I'll put the link for this entire playlist, or maybe there is one video on this channel for end-to-end Power BI learning. I'll put that link also, and maybe if you want, if you are interested in learning that, you can just check that out. And in case of any doubt, you can of course feel free to ask any question wherever you are stuck in. So here I will just do this adjustment, and let me just make it a little small, just equal to this. All right, and maybe we can expand this a bit. The data is literally heavy, that's why it is taking a lot of time. Maybe for the licensed version it would be easy to use and handle this sort of data, but for this free version though, it is absolutely difficult. Okay, so what I did is I just copied pasted both of these two charts, and now into this one by one I'll go and I'll change the x-axis value. This is adjusted over here, and this I will adjust over here. Let me do a little bit of adjustment over here. Oops, I'm so sorry. Okay, so I'm not going to invest the time in this adjustment. All right, let me just make it a little quick. All right, like you understood what exactly that has to be done, right? It is literally becoming difficult for me to handle that, right? Old balance destination, I'm just going to remove this one, and instead of that what I'll do is old balance origination. This is what I need to use over here, and instead of saying sum, I'm going to say don't summarize, and the same thing I will require to do for this one. Why it says old balance? Yeah, old balance origination is something which I needed. Okay, now in this chart again I will just remove this new balance destination, and into this new balance origination I need to pick new balance origination. This is what I require. I'm so sorry, this because of its speed it is turning out to be really difficult, and the video is becoming a little lengthy, otherwise it could have been very interesting. Okay, all right, so we are done with creating all the required visualization. What we can do is let's just collapse this and let's just try to understand it. Exactly the same thing which I was explaining you in the previous visualization in the very beginning. What you can see over here is just the order position of the charts are different. So what you see over, sorry, what you see over here is old balance origination, right, is old balance origination and the amount. These two are the bigger contributor in predicting the frauds. Okay, like you can see over here, these all are the points which indicates to the fraud. Here also these all are the point which indicates to the fraud, and like you can see how dense it is, right? and that's where it is showing that it has a strong contribution in predicting the frauds. And there are other analysis which you can also do. I have created probability also, so I would highly encourage you to go ahead and try to utilize probability from this list, right? SMOTE probability, like you can see SMOTE prediction. I would also encourage you to compare the prediction from of SMOTE prediction and ensemble prediction, both of these two, and against this SMOTE probability, try to check it out, compare it with is fraud, which was the actual fraud indicator, right? And let me know your observation into the comment section. I'll be very happy to interact with you and do the collaborative learning. Until then, happy learning, wish you very all the best. Let me know your thoughts and your analysis into the comment. Thank you once again, wish you very all the best.